Alright folks, so we're going to continue our work on derivatives rules, and we're going to start with some rules that you've probably already been using at this point, even though you didn't even know that they were rules. So sum and difference rules work exactly how you'd expect. So if you're adding two functions together, so f plus g, their derivative is the sum of the derivatives, f prime plus g prime. So what we mean by that is if I had like x squared plus x, and I was taking the derivative, that would give me the derivative of x squared is 2x, and then the derivative of x is 1. Okay? Subtraction works the exact same way, right? Because subtraction is really just negative addition. So that one, like I said, you've already been using that rule. We're just giving it a name, so you don't have to burn a whole lot of brain power on this one. Product rule, though, this is new. So product rule says if I have f of x times g of x, the derivative of that is going to be the first function times the derivative of the second, plus the derivative of the first function times the second function. Okay, so this does not necessarily work exactly how you'd expect. So what it's not is f prime times g prime. Okay, we're going to do this in sort of a different order than how I printed it, I think. So let's do an example of product rule first, and then we'll talk about why it's so different from the sum and the difference rules. So let's take our two functions here. So notice we're multiplying, so we're going to use product rule. 2x plus 1 is the first function, and then the derivative of 2x is 2, the derivative of 1 is 0, and then x minus 3 is the second function. The derivative of that is 1, right? Okay, so these are our functions, these are your derivatives. So this says to take 2x plus 1 times 1. So f prime of x is going to be 2x plus 1 times 1 plus x minus 3 times 2. Okay? And then we can simplify. So obviously multiplying by that 1 doesn't change 2x plus 1, but here we want to distribute my 2. And then I can combine like terms. So that's my f prime of x. So a little more complicated than multiplying the derivatives together, because if we just multiplied the derivatives together, we would get 2 times 1 is 2, and that's obviously not the result we got here, right? Just to be clear, so I called this f of x, I probably should have called it something else, but if I'm following my model, my first function would be f, my second function here would be g, and then here's f and g down here, and here's f prime and g prime down here. And then I'm just plugging in what I get into this rule. So that's product rule. Here's the reason why it's so complicated. Here's an example that you can connect it to understand why it's so complicated. Again, deriving these rules is kind of outside of our scope here. So suppose we draw a square that's 5 feet on a side, and then we make those sides 2 feet longer. So here's our first square, 5 feet all the way around, right? And here's our second square, which is obviously going to be 7 feet all the way around. And then by how much has the perimeter changed, and by how much has the area changed? Well, you are familiar with perimeter and area. So perimeter is the distance all the way around. So 4 times 5 is 20. 4 times 7 for our bigger one is 28. And then area is base times height, right? So 5 times 5, 25. Area here, 7 times 7 is 49. Okay, so notice the change is a lot bigger for area versus perimeter. So perimeter, when we're adding them together, I increase by a total of 4 times 2 is 8 feet, and that's exactly what I get, right? But because we're multiplying for area, the increase kind of compounds itself, right? So that extra 2 on each side is being multiplied together, and the result is the area increases by a lot more. That's exactly analogous to the product rule. In fact, we could write this as a calculus, sort of a calculus problem, and we'll get into that a little bit in the next unit. But that's why this product rule is different, and hopefully that will help you remember to do this. So you can't treat it just like addition and subtraction. We have this rule to capture this greater difference for multiplication. All right, let's do one more example before we move on to product rule. Okay, So find y prime if y equals x squared minus x plus 1 squared. So notice you could do this if you wanted just by multiplying these together first, but that's far from the easiest way to do it, right? Same thing up here. I could have, used FOIL or a Punnett square to multiply these together, and then I have a polynomial that I could take the derivative of, but this is actually easier, okay? So if it's helpful to you, you can write that my function f is x squared minus x plus 1, and then squaring means multiplying by itself. So g in this case is also going to be x squared minus x plus 1, right? That means the derivative of each. Derivative of x squared is 2x. Derivative of negative x is negative 1. Okay, and then we want f times g prime plus f prime times g. Well, f times g prime is going to look like this. X squared minus x plus 1 times g prime, 2x minus 1, plus f prime times g, and it's really the same thing, right? 2x minus 1 times x squared minus x plus 1. All right. So that is product rule. And obviously, if I wanted to, I could multiply these all together and combine like terms. Unless we specifically ask you for that, though, in AP Calculus, it's okay to leave your results unsimplified. So that is product rule. Make sure you capture all these notes before we move on. We're going to do one more rule in this video. All right, last one is quotient rule. So dividing two functions. So f of x over g of x. This is the hardest one to remember. You will memorize it sort of naturally. I don't think you'll need to actively try to memorize it, and you can look it up until you need it. So it is the bottom function times the derivative of the top function. So it's starting to look like product rule, minus the top function times the derivative of the bottom, all over the bottom function squared. Okay. So again, a little bit harder to remember, but you will have it memorized quicker than you probably think. So we'll do a couple examples here. So in this case, we can say, again, I called it f of x, I should have called it something else. We can say f, the top function is just 1. That means f prime is 0. Top function, or the bottom function rather, is x squared, and then its derivative is 2x. Okay, and then I just follow the model. So g, so x squared times f prime, which is 0, and then minus f, which is 1, times g prime, which is 2x, all over g squared. Well, x squared is g. You square that, you multiply the exponent, so that's x to the 4th. So there's my derivative by quotient rule. Notice we could have done this one by power rule too by rewriting it. We're going to get the same result. So the big takeaway here is pick whichever way is easier. So for example, this is the harder way to do this one. So 0 times this is just 0. I get negative 2x on top, x to the 4th on the bottom. And then remember, I can subtract these exponents. So what I get is negative 2 over x to the 3rd, or negative 2x to the negative 3rd. These are both correct. And this, you can try it if you did power rule on this by rewriting it as x to the 3rd. We get exactly this. Okay. We'll do a harder one. So here, my top function is 5x plus 2. Its derivative then is 5. My bottom function is x squared minus 1. Its derivative then is 2x, right? And then again, I just follow my model. So x squared minus 1 times 5 minus 5x plus 2 times 2x all over x squared minus 1 squared. And again, it's fine to leave it like this. If we needed to do something with this function, we'd want to simplify it. But for our purposes here, we can leave it alone. So that is quotient rule. So all you're doing is following a procedure. And notice there's more than one way to tackle some of these, so pick whichever way is easiest to you.